Morning everyone, and a very warm welcome to this webinar on underground packaged plant rooms. Thank you very much for joining us. Just a few housekeeping things before we start. Hopefully you can hear me by now. If you can, then you've obviously set up your audio all right. If you are unable to hear me, well, you can't hear me, but hopefully by now you can, and you should be able to see my title slide of the presentation entitled Modern Underground Packaged Plant Rooms. If you can't see that immediately, then you should be able to find it somewhere on your screen. So just make sure you can see that. Also, the chat function should be available to you. You can use that to basically fire any questions at me, anything at all. I'll do my best to answer questions as we go along, but probably some of them I'll have to wait until the end. But I want this to be hopefully an interactive session. This is a really exciting topic, and it's something that we've worked on very hard the last few years. And I've been really looking forward to talking to some people about it. Now, we're going to cover a few topics in relation to underground packaged plant rooms. Firstly, we're going to look at why we might want to build an underground plant room, why we want plant installed underground. Some of those will be obvious to you, but there might be things you haven't quite thought of. And we're going to look at some of the common problems associated with putting plant underground. And particularly, we're going to look at some of the issues with putting potable water systems underground, some of the issues associated with that, because obviously there are many safety considerations there. And we're going to look at a new approach to underground plant rooms, which is very exciting and solves actually many of the problems that we've been contending with for a number of years. So just a few notes about us as a company, if you're not so familiar with us. We're Dutypoint. We've been going since 1976, and we're all about fluid technology. We love innovating in fluid technology, whether it's pumping systems, storage, wastewater, clean water. We're all about setting the bar for innovation in fluid systems. And we do a lot of work in the construction industry with utility companies and with property owners across the UK and overseas as well. We're based in Gloucester down in the West Country, which is where I'm talking to you from today. That's also the site of our UK manufacturing. We also have offices in London and Loughborough as well. And really our mission is to solve some of the complex challenges to do with fluid systems. And we're going to talk about one of those very interesting complex challenges today. So just to remind you again, please do feel free to fire any questions at me at any point throughout the presentation, and I'll do my best to answer. So a bit about me. My name is Chris Lang. I'm the product manager at Dutypoint, and really it's my job to kind of oversee all aspects of our product portfolio, and working both with the technical side, so our new product development team, and also closely with our marketing and our sales teams, and making sure that we kind of are serving our customers' needs, and we're keeping up to date with all the things that you guys as specifiers, as contractors, are dealing with, all the problems that you're facing, and make sure we actually produce solutions that will really serve your needs and help you solve problems for your customers. So to start off on underground, why would we want to put plant equipment underground? There are a few obvious answers to this question. Hopefully some of these are obvious to you. Of course, plant is something that particularly architects, developers, they want to be out of sight and out of mind. They don't want expensive above ground space being taken up by what they see as kind of unsightly plant equipment. If you've got a hotel, for instance, your plant room might take up the equivalent of 4 hotel rooms, which actually as a developer, you'd rather they were used as hotel rooms. So what we want to do is regain that prime above ground real estate, that space that we could use for revenue generating activities rather than plant equipment, which doesn't generate revenue. So really it's about reclaiming that above ground space, taking the plant, putting it underground, out of sight, out of mind. Now, a lot of retrofit projects we get involved with don't have sufficient plant room space for the plant that's required for whatever reason. I'm going to talk a bit about a case study later on where that was the case, but if you have projects where there just isn't sufficient plant room space available, of course, one option is to build more space, which is potentially very expensive above ground, or to put in temporary temporary type structures which can house the plant, which has issues with it as well. Of course, in some prime developments and developments in general, you don't want noise being transmitted from plant equipment into the rest of the building. And actually, what we're discovering is some consultants particularly are wanting to really take account of the noise footprint of the plant equipment that they're specifying. So actually looking at underground as a solution to unwanted noise is something that maybe not everyone's thought about before, but it's certainly something that we are hearing more of. And the other thing is very important when it comes to potable water or drinking water is placing plant equipment underground, and particularly water storage underground. It actually helps you to maintain a more consistent temperature. I think we're quite acutely aware of temperature changes at the moment. Obviously, we don't want water getting too warm to the point where you can get Legionella bacteria growth. And of course, we don't want it getting too cold to the point where it's frosting. And actually putting water storage underground actually does help you maintain a more consistent temperature. There might be other reasons that you might want to place plant equipment underground. I'd be really interested to hear any of those. So I'm pleased to please do fire away any of those reasons at me on the chat, and that would be really great to see. Now, of course, that's all very well, but there are some problems associated with putting plant equipment underground. The installation's often expensive and time-consuming. Of course, you've got to take account of any existing services that are underground, spend time surveying, civil engineers' involvement, civil contractor costs. It's a very expensive, time-consuming process. Of course, you've got to create an excavation, and potentially site operatives have to make entries to that excavation. And of course, that is something that we want to avoid where possible. You know, sending people down into an excavation is always a potentially hazardous environment. And the less we do that, the better, really. And that's the case with all these on-site health and safety issues. Now, concrete shuttering is another kind of big area that is a time-consuming aspect of putting any sort of equipment underground. You have to spend time constructing temporary shuttering on site. It takes weeks, lots of equipment, lots of specialist personnel are required. So the installation side is expensive and time-consuming. With putting in particularly underground tanks into installations, you get issues with groundwater. I'm sure many of you are familiar with these, but basically if you're in an area with high water table, essentially if you then put a hollow tank underground, that tank essentially wants to float in the water. So you get issues like the one in this slightly extreme example in the image that you should be seeing now, where this tank has basically floated up to the surface, which obviously shouldn't have happened. But it's a surprisingly common problem. You know, someone hasn't done their calcs properly, and they haven't provided sufficient downthrust for the tank, and the water creates upthrust. So that is a common issue and something that needs careful consideration, careful planning and calculation. And of course, water table can rise and fall in areas, so that's worth taking account of. Even if the water table's not high today, that doesn't necessarily mean it won't be in a few years' time. Now, when we're talking about potable water, of course, we have to make sure that water is very well protected. We have to make sure there's no risk of contamination whatsoever to that water. And just putting bare kind of potable water tanks underground is very problematic, because over the years you start to get groundwater seepage into those tanks at a very slow rate, but it does happen over the years. And if you're near anything like a landfill site, for instance, then of course you have to be very careful that there's no chance that years down the line there's going to be any risk of contamination to that possible water. And, you know, are there sewage treatment works in the area? Is there groundwater runoff? Is there drainage around? You know, there are many issues you want to think about when you're putting potable water underground. So those all need to be taken account of. And the fourth one here is allowing access for maintenance. Now, when you store any kind of water underground or any liquid underground, if you're then having people go down there entering the space where that water is stored, you've actually got a flood risk, because if at any point any sort of valve or any pipe work or the storage system itself actually fails, you could have potential for water discharging into the area where people are, and there's a risk of drowning because it is conceivable that someone could do this accidentally, fall over or something, and then they could be trapped underground. Can they? Is there a mechanism for removing any potential flood water? What happens if there is a problem and they need to get out quickly? You're sending people underground into a confined space, and there are regulations to do with working in confined spaces, of course, but those are quite general. So actually, when we're creating these installations, we have to take account of all these issues. Of course, there's air quality issues. If you're in an area where there's potential contamination of air, then you have to have specially trained people with breathing apparatus to go down. Obviously, there's specialist confined space training that is required. Generally, if you're going into a confined space underground, you have to have 2 trained operatives, which of course adds to the overall lifetime cost of maintaining this underground system. And if that's installed for 30, 40, 50 years, you're adding a significant amount of lifetime cost just for maintaining the system because of the special training required. Is there a safe escape route? Often with underground possible water systems that we've seen, there's a very narrow access hatch and there's a ladder, and therefore you have to have a second person with a harness arrangement to help someone get out as quickly as possible. And is there a is there a solution to this? Is the question. But we think all these safety issues can be mitigated, of course, with special training. But you're adding to the cost. You've got all these issues to do with water contamination, and in a situation where you're supplying possible water to a building, of course, if there's a problem, you want to get maintenance personnel there very quickly. And when you're in a situation where, in order to enter the plant room, you need special training, most people can't just go down there and solve basic problems. You'd have to call in specialist personnel as quickly as possible. So there are a few issues to contend with there. Actually, here's an example of some concrete shuttering just to show you. It's a bit of a complex arrangement, but it's basically very time-consuming installation. But we'll look about how to mitigate that later. And actually, here's an example of just a confined space entry here. Someone with some harness equipment going down. Now we've seen a few systems like these on the market for a few years, and we just kept on thinking, there must be a better way. And of course, being in the industry, we hear about a lot of the problems that happen with these systems that are on the market. Sometimes they're not built strong enough to withstand the pressures of being installed underground. Often they're made of GRP, which is not an inherently strong material from that perspective. So the strength, of course, is in the concrete, but then we've seen examples of underground plant rooms being installed and not being strong enough to withstand the pressures. We've seen an example of groundwater ingress into possible water storage tanks, which of course is pretty disastrous. We've seen unforeseen maintenance costs. We've seen failed tanks, failed systems, which actually have to be abandoned and filled in with concrete because they've failed basically. So a lot of this, I think, it puts people off installing possible water tanks underground. But there is a new approach, and we're very excited about this new approach, and it solves basically many of the problems that I've just been talking about, which hopefully you'll think is great news. So the new approach, what is it? Well, what it does is it genuinely does allow developers to regain that prime real estate by locating central plant equipment underground. So you can use dead spaces like car parks, driveways, space that is necessary, but actually you don't want plant equipment there. The confined space issue is a massive one, and actually we've come up, there is a solution to many of the confined space challenges, making maintenance much more viable over the lifetime of the unit. there is a solution which allows much faster installation. And we're talking days rather than weeks, which is really good news. And the new approach uses much less concrete than the old approach. So, using much less concrete, less damage to the environment. It allows you to specify a fully packaged solution from a single supplier, which I think is good news from a specifier's perspective. There is built-in protection against the drowning issue. So putting water tanks underground, there's a risk of drowning for anyone going under there. There is an approach which solves that issue and many others. And of course, when you're doing these prefabricated plant rooms, which I'm going to talk about, you're limited in size by what you can transport. So actually, what you can do, which is a new approach, is actually install multiples and network them together. So if your plant requirement is greater than that can be transported via road, you can build a modular network of plant rooms, which is really exciting and actually allows lots more flexibility. So what is this new approach? Well, I'll show it to you now. So this is, we call it the OPTIMISE, and we think it solves many of the problems associated with underground plant rooms. Now, there are many features here that I'm going to go through and talk about. So here, this is a render of one installed underground. So you can see the kind of grass at the top. There's a long access hatch that goes right along the length of the unit, and as you can see underneath, there's a staircase, which I'll show you another view there. So this is taking the surrounding items away. So rather than having a ladder with a full size with a small access hatch, you've got this long, basically oversized access hatch and a full size staircase. And immediately that takes away one of the major issues, which is safe access and safe escape in the event of an issue. So someone having to climb up a ladder is much slower and less safe than someone just walking up the stairs. So if someone has to go down into this unit, if they have an issue, and they need to escape quickly, they just walk up the stairs. It seems like an obvious solution, but actually it hasn't been done until recently. So that actually takes away one of the major issues to do with working in confined spaces. Now, the other issue that I mentioned earlier was the risk of flooding. And if you just put in a kind of a watertight shell and then put a tank inside it, if that tank fails, the water just goes into the shell and could drown someone. And of course, you've got this connected up to a mains water supply. And of course, unless there's any valve to stop it, the mains water is just going to carry on pouring into this unit and could potentially drown someone. So this risk has been mitigated in this design here, but with the inclusion of an underfloor bund. So basically, the floor of this plant room is all mesh, and there's a space there's a void underneath the unit there that is equivalent or greater than the size of the storage tank. So if there was any sort of failure for whatever reason, and all the water exited from that storage tank, rather than exiting into the area where there are people, it just goes under the floor, and then there are just pumps to pump it out, and there are automatic shut-off valves for the inlet valves. So if the sump pumps start pumping, the inlet valves from the mains water automatically get shut off. So the risk of drowning, is greatly reduced with this system. I'll show you another view as well. So unified control panel. This on the right hand side, you can kind of see there. There's ducts for the pipes to go in and out and for cables to go in and out. So there's a cold water booster set in this example, but conceivably you can install any kind of plant equipment in here. But this unit particularly is designed for basically a complete sort of possible cold water pressure boosting system. Now, we talked about the time installation takes, and in this view here, actually, you can see the plastic surround of this unit. Now, this is actually prefabricated concrete shuttering, which surrounds the unit. Now, normally when you install something like this, you have to you can crane it in, and that's all fine, but then you have to spend quite a lot of time actually constructing the concrete shuttering around the unit. But actually, we found a way to build in this prefabricated shuttering actually in our factory. So when these units leave us, they've already got the shuttering all there, so it doesn't have to be done on site. And now that leads to massive time savings. Rather than it taking weeks to do the shuttering, it's already there. It's all done. So that's potentially weeks taken off the installation time, and plenty of labour hours taken off the installation time. And that is a really exciting development, because it just cuts the installation costs massively. And just to show you what it looks like from the outside, this is a photo with the shuttering all in place. So this is all one unit that can be installed all in one go. They leave the factory on the back of a low load lorry, and they just craned into place on site, and just takes many of the challenges to do with installing these systems underground out of the window. Also, actually, another nice feature to highlight here is that you can see in the top, just at the top of the sort of opposite the top of the staircase, there's a safety warning light system. Now, what we've done is incorporate a system of sensors that test things like the temperature of the air in the plant room, the air quality, and also monitoring for any potential flooding. And as soon as someone opens the access hatch, they see these warning lights, and there's signage next to it to say, okay, green light means yes, you can enter. Red light means no, there's an air quality issue, don't enter. Blue means there's water been detected in the underfloor area, so there's potential flood risk. So be careful before you enter. And this is a feature that just hasn't been seen previously in an underground package possible water pumping unit, and it just mitigates many of the risks associated with working in confined spaces, to the point that in most cases you could maintain this system just with one person that doesn't necessarily need to be confined space trained, and there's mechanical air ventilation built in. So the air quality is constantly maintained, so there's no need to carry breathing respirator equipment. And again, there's no need for the special training. So the maintenance costs, as I've said before, can just be dramatically reduced over say a 40 or 50 year lifetime of this unit, which is really good news. Now, I wanted to show you a sort of a bit of a case study that we worked on fairly recently. We supplied one of these units to a holiday park in Norfolk, and this is actually outside our factory. You can see it being loaded onto the back of a lorry there, and that's it. I'm going down the road. Now, one thing that can greatly increase transport costs is if these units go over a certain width, you need to have an escort vehicle. So what we've done is design them such that they are not outside the width that require that, greatly reducing transport costs. Because when it comes to offsite manufacturing in general, one of the big issues, of course, is actually getting these big, heavy prefabricated units to site. So it's important to design them in such a way that basically those issues don't add massively to the cost. So that's just something to be aware of. And this is the unit actually within the excavation itself. So you can see the excavation at 45 degrees, which is fairly simple for a civils contractor. You can see it, and it was basically just craned onto the base like this, in a very simple process. And this shot was taken within about 2 hours after the unit arrived on site. So you can just see the time involved in installing these is just so much less than equivalent systems. And this, if you like, is the end product. So on this holiday park, they needed some additional cold water boosting capacity. They didn't have the plant room space, and as a holiday park, they didn't want lots of unsightly plant equipment. And you can see the access hatch there to this unit is nicely hidden away. It just blends in with the environment, and it's out of sight and out of mind. And we've even done these in with, we offer a choice of access hatch colors to kind of blend in with the environment as clear as possible. It could be in a grass area like this. It could be underneath a driveway or a car park. There are many options. And this here is the inside of the unit. Excuse me. So just to highlight a few features when you're going from left to right, you've got a unified control panel with an HMI touchscreen. You can operate all the parameters of the plant room from that central touchscreen, and also it's got a SIM card unit installed. So this unit can actually be managed and monitored from anywhere in the world over the internet, and that's very important. Just because it's out of sight, actually, you're not necessarily always going to pick up on problems as quickly as a surface level plant room, which is easily accessible. You can hear warning sirens, or you can send someone in daily to check for any warning messages or lights. Actually, having the remote management is a very key feature, because it allows you to actually to be aware of the problems before the occupants of the site actually aware of them themselves, which is very good. Obviously, you can see a lot of the pipework duct. You can see the air handling unit on the left-hand photo on the top right. You can actually see a thermostat unit in the bottom left, which is one of the sensors for monitoring the temperature and the environment in the plant room. There's a variable speed booster set, 3 pumps there. The inverters are actually all mounted in the control panel. One of the big changes actually for us was thinking about the plant room as a system in its own right. So rather than thinking of a plant room as a space where various systems are installed, actually this whole plant room is a system, and there are many factors that all have to work together to make the whole thing work. So, for example, there are, again the left-hand photo, you can see the outlet pipes from 2 sump pumps which are underneath the floor. Now those are linked to the warning light system, and they're linked to the inlet valves. So if the sump pumps start running because their float switches have detected water, the system knows to shut off the inlet valves because there's potentially a leak, and it knows to activate the blue warning light, which means that which just indicates to any people trying to enter that there's a potential flood risk. So all these factors have to work together, and there has to be a unified control system for all of those. Now that hopefully gives you a bit of an idea of what we achieved here. And if you look at the staircase, it's just a very easy way to get in and out, and that is really key for maintenance personnel. Actually having the peace of mind that they know they can exit quickly, not having to go down a ladder through a really narrow access hatch. We've not had anyone sort of express any reservations about working inside one of these because it's so easy to get in and out, and having the maintenance guys feel safe to go in there is really important, and it's really a key thing for the occupants of this site. Now I'm just going to review questions really quickly. So someone has asked about if the system can be used for firefighting equipment. There's no reason why not. There are certain standards governing firefighting equipment so there are sort of various control features required for any firefighting equipment, but that can certainly all be incorporated. Someone else has asked about what if the water table is really high. Actually, this site did have a very high water table, and it is this unit in particular is designed in such a way that it can be installed even if the water table is right up to the top of the unit. It has basically been designed assuming high water table areas, and I won't go into all the details about all the calculations and everything. There's not quite time, but if you'd like to talk more about that, feel free to get in touch with our team, and they can go through all that with you, and all the issues to do with water table. Another person's asked, is confined space training required for access? In most cases, no, because it does have features of confined spaces, but many of the common risks associated with confined spaces, like air quality, safe entry and safe escape, many of those aren't present here. So generally, I mean, it is somewhat site specific. If it was, for example, in an isolated area, then you'd probably have to do a site specific risk assessment for that. But on the whole, we would say this wouldn't need to be serviced by kind of 2 confined space trained individuals. It would normally just be serviced by 1, and they wouldn't necessarily need to be confined space trained. Now, just to kind of summarize what we've been through, the problems with putting plant equipment underground, the confined space restrictions I've talked quite a lot about, and here are some of the features of this new approach that we talked about. So the air quality is an issue, so we've installed mechanical ventilation. The safety warning light system ensures that people are, can be really assured that when they see that green light, that it's perfectly safe to enter the system. The full-size staircase also, adds a lot of confidence, and it adds a lot of reassurance to anyone entering that they can escape quickly if they need to. The flood bund, of course, is a massive feature for protecting against potential drowning. We think that's really key when you're putting big sort of storage systems underground. Obviously, component backup. I didn't actually mention this earlier, but in most cases we would sort of back up all the key systems with a battery. So, for example, the inlet valves are operated with low voltage, and there's a battery backup in case the main supply fails. And so in the case of a mains failure, there's power there to close the inlet valves, and then they can be reopened when power is restored. And of course, the automated nature of it, the fact that it's all one system, it's not lots of different systems all coming together. It's the plant room itself is one system. That's how I would suggest thinking about it. And so the second issue is the installation. Now, hopefully you've seen the pre-installed shuttering greatly reduces the cost of installation, reduces the amount of concrete required, but also it reduces the amount of time spent on site. It reduces the number of times that people have to actually enter the excavation. So there's a massive safety benefit as well. And of course, the protection of the possible water itself. So actually not having the the possible water storage in direct contact with the outside, so there's no sort of chance of groundwater seeping in. As you can see, there's a sort of clear air gap between the sort of the underground world and where the storage is actually where there's actually storage. And of course, you've got a mechanism for removing the groundwater. Now, hopefully, that you can see the benefits of this new approach. Just glancing down the questions now. Question about whether it be suitable for use on a social housing development. I can see absolutely no reason why not. Absolutely. It'd be great to talk more about that. Another question about frost protection. Yep, very good point. So there is frost protection. There's a temperature sensor, and there are a couple of electric space heaters there. So that could happen, absolutely. So yeah, there is frost protection there, which is good. And another question about air intake. So yeah, there is. I think you might hopefully seen one of the earlier photos. Let me just drop back a bit. Hopefully see the air intakes at the top of that image there. And actually on the Norfolk site, we had to protect those with just with a little wooden hut to stop any, I think it was to stop snakes getting in. But yeah, obviously you need to have some sort of air inlet. So that would be fairly site specific, to be honest. Another question about remote management and monitoring. I think I mentioned that earlier, but yeah, it's a highly recommended feature that these units are installed with full remote management, and that's a two-way system. So it's not just a monitoring system where you receive error messages. It's a system where you can actually control any of the features that you can control from the little touchscreen inside the unit. You can control remotely as well, and that is a massive time saver, and in many cases it means that we from our headquarters can actually make adjustments to the system without having to send an engineer to site, which could potentially save the user a lot of money over time. Now let me just pop back here. And I guess the key in all of this is safety. This is what our MD said about this system. Actually, it was all about safety during maintenance, during the installation, was the key thing to think about here. Would always suggest being this is a safety first approach, and anything underground, safety is always the primary consideration, and that's what this new approach allows, I think. Another question here, and please feel free to fire questions at me now. We're kind of wrapping up here, so please do keep the questions coming in. It's great to hear them and great to talk about things, and there'll probably be some things I haven't covered because obviously it's quite a detailed topic. Of course, we can talk further another time, but please do fire the questions. Another question here about installing hot water boilers and heat exchangers. Yeah, absolutely no reason why not. Essentially, what this is a flexible space that can be used for anything. So it can be used for pumps, as we've seen here, but it could be used for all sorts of things. Yeah, heat exchangers and boilers, why not? Because all the ventilation is there. You've got the ducts in and out for pipe work. You could do the same with gas. Absolutely no reason why not. So yeah, we think there's many exciting possibilities for this this new approach. Now, I just want to, before we wrap up, I just want to mention one more thing to you. If you're around in London next week, we're running a little event called Future M&E in partnership with a company called Shenton Group, who are all about generators and CHP systems. It's in Covent Garden. Venue's called Ice Tank. It's near Tottenham Court Road Tube Station. We're running it across Thursday and Friday next week. There are 3 different CPD sessions, about an hour each. So if you do need some CPD points, that's a great opportunity to get them. We've got some new products on display, and a lot of the Dutypoint team will be there. I'll be there as well. Be great to meet some of you if you're around. Please do come and say hi. I was on your webinar if you do come along. There's lunch and refreshments available. Lunch is from 12:30 to 2, so you can fit that around some of the CPD sessions which run throughout the day. If you can just drop in briefly, it'd be great to see you, or come for the whole day and go through, or come for a part of the day. So that, yeah, there are 3 different CPD sessions that kind of run on a rolling basis throughout the day. There's one on generators, which Shenton Group, they're real experts on generators, and they do a really good CPD session on those, and also on CHP systems as well. And we're running a CPD session on cold water boosting and best practices in design and specification of cold water boosting systems. So it'd be really great to see you there if you're able to come along. It's quite a small, intimate event. The CPD sessions are limited to 25 people per session. So I would suggest you register for the event and for those sessions, and you can do that at dutypoint.com/future-me. That's dutypoint.com/future-me. It's just a little form to fill out to register. It's a free event, and there's lunch and some really good lunch and refreshments provided throughout the day. So it'll be great to see you there. Now that kind of wraps up this session. If you do have any more questions, I'll hang on here for a little bit, but yeah, I've really enjoyed talking to you today, and thank you for all those who've asked questions. That's really helpful. So please do get in touch with us if you want to talk further. So just to remind you, my name's Chris Lang. You can reach me by just calling into the main Dutypoint number, which you can see on your screen now, or talk to our team about any projects you might have coming up, where you're maybe considering an underground system like this. It has potential to sort of make massive savings for building occupiers, saving construction costs. So it's a really exciting approach, and I think customers, developers are going to love it. So thank you very much for joining us. As I said, I'll hang around for a little bit if you've got any further questions, and if not, just thank you for joining, and hopefully we'll be in touch soon. And if you're around in London, look forward to seeing you at the future M&E events. So thank you very much. Okay, if anyone's got any questions at all, do please fire away. Just another note to say there is more details about the system on our website at dutypoint.com. If you search for the Optimize is the name of the product, you'll find some information there. There's sort of data sheets and case study and all the technical data. It's all available there. And if you need any help in selection, please talk to our specification team, and they'll be very happy to help you. So any questions at all? Okay, I don't seem to be any more questions for now, everyone. So I'm gonna kind of put a close everything there. If you do have any questions that you kind of think of in the next few days that you forgot to ask today, do feel free to drop me an email. My email address is chris.lang@dutypoint.com. Lang is L-A-N-G. chris.lang@dutypoint.com. Be happy to kind of answer any other questions you might have. Or if you just want a general discussion, then feel free to get in touch on 01452 300 592. That's 01452 300 592 is our main office number. So I'll look forward to talking to you. Thank you.